So after the December 2019 sum, we will also have a look at the May 2019 sum. Again, in this case, they haven't given the diagram, but this one is a comparatively easy diagram. Okay, see, epicyclic gear train has an annular wheel, the bigger outer wheel, annular wheel, which has 54 teeth and meshes with a planet wheel B. So there is a planet wheel which gears with the sun wheel C. So there are three. There is the sun wheel which will be in the center. There will be a planet wheel which will be outside the sun wheel, and there will be a total bigger outer wheel, annular wheel. I have created the 3D model and will be showing it to you, but you should be able to imagine this right now. The wheel B is carried on a pin fixed to the end of arm P. So there is an arm P which is connecting the planet gear and the sun gear, and that arm P is rotating at 100 rpm above the axis of the wheel A and C. So if the wheel makes 20 rpm in clockwise sense, wheel A is what? Annular gear. So A is rotating at 20 rpm and the arm is rotating at 100 rpm in anti-clockwise direction. Okay, and C has 24 teeth. So we have to sketch the arrangement, that is we have to make the 2D sketch that I have done it in the answer. You can see it, and we have to determine the rpm and sense of rotation of wheel C. That is, we just have to find out the rpm of wheel gear C. So this is the 3D model that I have made of the current question. As you can see in this, the yellow one is your sun gear, the grey one is your planet gear, and the blue one is your annular gear. Okay, so currently the sun gear is held constant, it is stationary. So about that the planet gear is rotating, and about that the annular gear is also rotating. Okay, and see, here is your arm. This is the arm connecting the sun gear and the planet gear. So this can also be used as a output shaft. Okay, if you connect it over here. So this is how this system is operating. If you have another planet gear over here, you add another planet gear over here, this arm can be extended, and through the center you can have a shaft which will be your output shaft of the arm. So this is your current question's 3D model. I have drawn the 2D model in the next step. So I have drawn the diagram and written all the given data first only. Okay, and I have drawn the table as usual. Because it is an epicyclic gear train sum, we need to do this table. So what is the first step? Fix arm P and give +1 rotation to any gear. I have selected gear C. Okay, so this will be 0, this will be +1. If I give +1 rotation to gear C, what will be the RPM of gear B? Gear C and gear B are directly meshing with each other. So what will be the formula? NB upon NC is equal to TC upon TB. Okay, so it will be NB is equal to TC upon TB into NC, and NC is +1. So it will be TC upon TB. But these gears are externally meshing. Okay, these gears are externally meshing. Because they are externally meshing, the direction will be reversed. So it will be minus TC upon TB. Okay, what will be the RPM of gear A? A is meshing with B. A has no connection with C. A is meshing with B. So RPM can be written as RPM of A upon RPM of B is equal to number of teeth on B divided by number of teeth on A. So RPM of A will be TB upon TA into RPM of B. What is the RPM of B? Minus TC by TB. Minus TC by TB. TB cancels. We are left with minus TC upon TA. Now should another negative sign be put? No. Why? Because it is internal meshing. A has internal teeth. So it is internal meshing. So no another negative sign. Whatever it is over here, we will copy it directly. So minus TC upon TA. Okay, first row complete. Multiply all by M. 0 into M is M, 1 into M is M. Minus M TC by TB minus M TC by TA. Add plus N to all elements. And this becomes N. This becomes M plus N. This becomes N minus M times TC upon TB. This becomes N minus M upon M into TC upon TA. Okay, so this is done. Now to find the values of M and N, we will require two equations. Well, they have given us two equations. They have given us the RPM of the annular gear A 20 and they have given us the RPM of the arm P. Okay, this is clockwise, so it is negative. This is anti-clockwise, so it is positive. Okay, so what is A? A annular gear here. This is our equation. So equating these two, we will get n minus m into Tc upon Ta is equal to minus 20. It is clockwise. Okay, and what will be the another equation? Np. From our it is n. So n is equal to positive 100 because it is anti-clockwise. Okay, so this becomes our equation number 1. Solving equation number 2, simplifying it, what are we going to get? N minus m into Tc. Number of teeth on C is 24. And what is number of teeth on A? Number of teeth on A is 54. Okay, so substituting these values, this will be our is equal to minus 20. Is equal to minus 20. This will be your equation number 2. Okay. So using these two equations, we can find out the RPM of gear C. Okay. So n is equal to 100 and this one will become, so we will substitute 100 over here. 100 minus m into 24 divided by 54. 24 divided by 54 is equal to minus 20. Taking this over here and this over here, it becomes 100 plus 20 is equal to m into 24 divided by 54. So m is equal to 100 plus 20 is 120 into 54 divided by 24. So it will be 120 into 54 divided by 24. It is 270. So we have value of n, we have value of m. They have asked us to find out the value of NC. So NC is what? M plus N. So M is 270 and N is 100. Okay. So NC becomes 370. And because it is positive, it will be in the anti-clockwise direction. So NC is 370 RPM in anti-clockwise direction.